Unit 4B, Lesson 1. In this lesson, we're going to discuss different ways that we can obtain data. And then later in the lesson, we're going to discuss how we can find margins of error for surveys. First, we're going to talk about 4 different methods we can use to collect data. The first one is a census. This is a study that obtains information from every member in a population. A census costs quite a bit of money and it is very time consuming, so it's not performed that often. The next one is a sample survey. We talked about this in the previous unit. We talked about the simple random sample. We talked about the stratified sample and cluster sample. Each of those just uses a portion of the population to represent the whole. The next one is a controlled experiment. This is a way to assess cause and effect relationships. Think about science class. You have 2 different groups. One's called the control, and then you only change one variable in the other group so that you can analyze how that affects the group, cause and effect relationships. The last one is an observational study. This is also a way to assess cause and effect relationships. The difference is that the researcher does not have the ability to adjust the variable or control the population that is a part of this study. They simply can just observe and take in that data. For our class, we're going to work with sample surveys most often, but you do have to be familiar with the other methods used to collect data. Sometimes one method is going to be preferable over another. Now we're going to go through how to calculate a margin of error. You see this all the time in polls and studies when talking about elections or a president's approval rating. When you see a president's approval rating, suppose it said that 45% of the population approves of the president, 55% then disapproves of the president. Down below, you'll see a margin of error, a plus or minus some value. Okay, that represents the margin of error. We're going to go through how we can calculate that value if we have some other information. The basic formula we're going to use is the margin of error is equal to z times the square root of p times 1 minus p divided by n. N represents the size of the sample we're using. P represents the probability of the outcome. In the example we just went through, 45% approval rating, so our value of P would be 0.45. Z is going to be a new value. That is a value based on the level of confidence. Suppose we went through the study and we want to be 95% confident in our results. That's going to affect the value of Z, and we're going to go through next how we find that value of Z. Here's a table we will use to find the Z value we need. This is a sheet I will give you to use. You are going to become very familiar with some of the values in this table. But before we dive into actually how to use this table, we need to get a further background on what we're actually looking for before we find the Z value. To further our background, we need to have an understanding on what a confidence level is and how we relate that to a bell-shaped curve, our normal distribution. So the basic idea formula for a confidence level, that is equal to 1 minus alpha times 100%. So now we're going to go through an example on a particular confidence level so that we can isolate this value of alpha and see how that relates to our normal distribution. So suppose we want a confidence level of 95%. So we set that equal to 1 minus alpha times 100%. Now we need to solve to get alpha by itself. So first we would divide by 100%. 95% divided by 100% is just leaving us with 0.95. That's equal to 1 minus alpha. Now to get alpha by itself, we would subtract 1 to the other side, which leaves us with negative 0.05 equal to negative alpha. If we would multiply negative 1 to both sides of the equation, we get a value of alpha to be 0.05. So we had a confidence level in our study of 95%. We use that to solve for this value of alpha. Now we're going to see how that relates, where we can see that on our bell-shaped curve. So recall our bell-shaped curve. It's symmetric about the mean, the average, which is right in the middle. For our confidence level, which is 0.95, we got that from the 95%, that is equal to 1 minus alpha. Since our whole area under the curve is 100%, which is one whole, if we take 1 minus alpha, that's equal to 0.95. That represents this portion underneath our curve, which means that if we take the portions to the right and to the left, that must be equal to our value of alpha. Since these are symmetric, they're the same on the right and the left, if this whole total is equal to alpha, that means at this point, I would take alpha over 2 and alpha over 2. That represents this area to the right and this area to the left. That total is equal to alpha, which we know is represented by 0.05 or 5% underneath the curve. Right now, I know this looks like a bunch of gibberish. Stick with me here. We're going to actually put in some values. I think this is going to make a little more sense on what we're looking for. Now we're going to go through an example of actually finding that z value using the table. We're going to stick with what we started with on the previous slide. The confidence level is going to be 95%. I'd say that's probably the most common confidence level used. We simplified that formula to isolate alpha, which we found to be 0.05. Then we related that to our bell-shaped curve. We said alpha over 2 would be represented on either side of our main region because this is symmetric. If we know our value of alpha is 0.05, that means if we take alpha divided by 2 or 0.05 divided by 2, we would get 0.025. So that represents this region over here underneath the curve. When we're looking for the z value, we're actually looking in the table for the area under the curve that is to the left of that alpha over 2 value we just talked about. So now to find this area, we know underneath the curve is one whole, 100%. So if we take 1 minus the area we have to the right, which is 0.025, that is going to leave us with the area to the left of that point, which is going to be 0.975. So this is the value we're going to look for in our table that I showed you earlier, and then we're going to find the corresponding z value. So if we go back to our table, we're looking for the value of 0.975, which I have highlighted here somewhere in the middle. Now to find the corresponding z value, we're going to go to the left. We see 1.9. So our value of z is going to be equal to 1.9 plus the value we have in the column, which is going to be 0.06. So now if I take 1.9 plus 0.06, we get a value of 1.96. So this is the z value we would plug into our formula to find the margin of error.